Can the GitHub Copilot build an entire game for you? Not a to-do list, not a calculator, but a real game, like the popular Flappy Bird game. Let's find out. In this video, I'm not just showing you random Copilot prompts. We are going to vibe code our way to a full-fledged Flappy Bird clone using every significant Copilot feature, like the chat, the edit mode, the agent mode, and even inline debugging. Basically, you'll see how far AI can go if you know how to talk to it right. So here's the plan. We'll start from scratch. Just me, Copilot, and a blank editor. First, we'll learn to set up the Copilot across browser, Visual Studio Code, and IntelliJ. Then we'll also learn about the fundamentals of prompt engineering. And then piece by piece, we'll make that little bird fly. From writing the code, to writing the physics of the game, to even polishing the UI. We'll tackle it all together. Every step will show you a different Copilot superpower. You'll see how the Copilot chat mode can explain the code line by line, how the agent mode can create and review the pull requests for you, how the edit mode can refactor your entire component in seconds, and how even Copilot inline debugging can help you debug and test like a real teammate. And yeah, it's not perfect like everything else. Sometimes it just goes wild, write nonsense, or even break your game completely. But that's the fun part, learning to guide it like a pro. So let us start the journey from prompt to playable and see if AI can really wipe code. Let's get started. So, GitHub Copilot. What is GitHub Copilot? In terms of the actual documentation of GitHub Copilot, they define it as an AI coding assistant that helps you write the code faster and with less effort so that you can focus more energy on problem solving and collaboration. So basically, it's like your awesome pair programmer, or I should say, your genius pair programmer, who is designed to make your life easier by not just writing one-liners. It can generate the whole functions, your test cases, and sometimes even the entire files. It is not just autocomplete, but I should rather say it is autocomplete on steroids. It just lets you focus on the actual problem solving. You don't need to babysit the syntax or the boilerplate code. Let's now see all the cool things that the GitHub Copilot can do for us. So the GitHub Copilot isn't just about suggesting the code while you type. It's actually becoming a full AI teammate that you can use in your dev workflows. Let's break down the awesome things it can handle for you. First, providing code suggestions as you type. So this is one of the most important features. Let's say you're writing code. Copilot will predict what you need next. It can complete a line, a function, or even generate the whole blocks of code. So it's basically an autocomplete, but with a brain. Not only this, you can in fact chat with the Copilot about your code. So instead of searching, let's say, Stack Overflow, you can literally ask Copilot the questions like, why is my loop infinite? Or how do I optimize this SQL query? And it will try to explain or suggest fixes. Next, the command line help. Trust me, this is so underrated. It might have happened with you that you cannot remember the exact git command or the grep command. Now, Copilot has your back in the terminal as well. You can ask, how do I squash commits? And it will tell you the command. Next, Copilot spaces. Now, imagine that you are working on a particular project or maybe a task. Then with the help of the Copilot spaces, it gives you the way to organize all of that context related to that task or the project, and then give that context to Copilot. Based on that, the Copilot will give you more fine-tuned and relevant project-specific answers instead of the generic ones. Next, it is PR descriptions. You no more have to do that boring part again. Copilot can automatically generate a neat description of the changes in your pull request. So no more wasting 10 or 20 minutes writing fixed bug in logic XYZ because user was stuck in infinite loop. So Copilot just drafts it for you. Again, saving time so that you can focus on the actual problem solving. Next, it is knowledge bases. Now this is an enterprise-only feature. How does it work? Let's say you have a company. You can just upload all your internal documentation, and then Copilot can use that as the context when chatting. So if you ask, let's say, what's our internal API for payments? it can then answer from your company's own documentation. Next, and this is quite an advanced functionality, and it is available only in the Pro Plus, Business, and Enterprise. It can actually make the code changes and submit a pull request for you. You would still have to review it though, but it will save you the grunt work. So in short, your Copilot is like a true coding partner, a genius coding partner that helps at every step, writing, explaining, debugging, documenting, and even submitting the changes. Now, GitHub Copilot is powered by OpenAI's Codex. So this is basically a model which is fine-tuned from GPT-3 and trained on large amounts of the public code. It was launched in 2021. By 2022, GitHub reported that Copilot was writing 30% of the code for developers who used it. And by 2023, this number had jumped to 46% in some languages like Python and Java. Now, Copilot is supported in all the popular editors like VS Code, JetBrains, Visual Studio, Xcode, NeoVim, basically all the big ones. It supports all the popular languages as well. Python, Java, JavaScript, TypeScript, Ruby, Go, C#, C++, PHP, etc. Actually, it can generate code even in niche languages because it was trained on a massive set of public code. The accuracy might vary, but it can usually produce something workable. So why do we learn it? Well, why not? We have to learn it because Google is tired of you, because Stack Overflow isn't your diary, because typing boilerplate, it's boring, because debugging alone, it is sad, because the future devs, they won't just code, but they'll co-code. It helps you prepare for the era that is coming up where the human plus the AI teamwork is indispensable. So let us now talk about the GitHub Copilot plans. Now, what are the GitHub Copilot plans? Well, you can think of them as different subscription tiers on Netflix. Each one of them will give you a bit more depending on what you need. So first we have the GitHub Copilot free plan. This is sort of your starter pack. This is where you will get all the basic AI code suggestions like auto-completions, snippets, basically help with everyday coding. It is perfect if you want to try Copilot and see what the hype is all about. You can think of it like tasting a free sample on an ice cream shop, enough to know if you like the flavor or not. Next, we have the GitHub Copilot Pro plan. Now, this is where it starts getting a little powerful. You can unlock advanced suggestions, inline chat with higher usage limits. It can understand your natural language prompts better. So you can just say, write me a Python function to bubble sort, and it will do for you. I would say this plan is for serious individual developers who want Copilot to feel less like autocomplete and more like a paid programmer. Next, we have the Pro Plus. Now, it does not only suggest the code, but it can make the code changes for you. It can create the pull requests and handle repetitive tasks. It's great for the people who want to speed up the automation even further. Next, we have the Copilot Business. Now, this is if you want to go team size. It is built for organizations and teams. You get everything that is in the Pro plus centralized management. So basically, there will be admins who can then control who can get the access. They can enforce the policies. Just make sure everyone is using it efficiently and securely. Imagine, let's say you are running your company hackathon, okay? So instead of setting up the Copilot individually for the 50 developers, you can just get a business plan and it can handle that for you using the centralized management. Finally, we have the enterprise plan. This is the big league guy. You get everything in business plus knowledge bases and advanced enterprise features. Knowledge bases is basically where a company can upload its internal documentation to provide the context to the Copilot, and then it can use that to provide suggestions and answer queries. And this will be, of course, based in the context of the company's own code and its own practices. So a very solid feature. So if I have to summarize, it's like not just having a personalized AI assistant that is trained on public code, but rather on your own internal know-hows. So definitely perfect for large companies that need AI tailored to their specific environment. So we have covered the gist of all the 5 plans that GitHub Copilot offers. By the way, a fun fact. Do you know that students and educators often get the Pro plan for free? And same for maintainers of big open source projects. You definitely want to check that out if you fall in either of those categories. So just to recap, the free plan is like try it out. The pro plan is kind of full power for the individuals. The Pro Plus is Pro plus some automations. And then the business is for the team. And the enterprise is for large organizations with custom needs. You can always start where you are and then move up if you need more. If you want to know in more detail about the features that all of these plans offer, feel free to head over to the GitHub official page where you can find all of these plans and all of the offerings in more details. AI feels magical, right? Tools like ChatGPT, Claude, Gemini, Copilot, they write the essays, they write even the code, poems, going artistic. But here's the truth. At the heart of it at all, they just do one simple thing very well. They predict the next word accurately. So, if you want better answers, you have to give better instructions to extract those good answers out of it. That's exactly prompt engineering. In this lecture, we'll break it down from the ground up what LLMs are, how do they actually work, their limits, and how you can talk to them effectively. Now first, what are LLMs? Well, the word LLM, as you might know, is a large language model. Now let us try to understand this word by word. First, it's large. Now why it's called large? Because they are trained on massive data sets. You can think all the books, all the websites, articles, code bases, way more text than any human could ever read. That's what they have been trained on, and hence the word large. Second is language. Now LLMs, they work with human language, not just English, but many languages, as well as many programming languages too. Third, model. Now in math and computer science, a model is just a system that learns patterns from the data. So basically, an LLM is a pattern recognition machine that is trained on language at scale. This pattern recognition machine basically represents a model. The language represents the second word, which is the language that they have been trained to work upon. And scale represents large because they are trained on massive data sets. So you can just think of LLM as a pattern recognition machine trained on the language at scale. That's what the LLM is. Now, I would like to add one more section here just for understanding and to see the contrast on how the LLMs work versus how the humans work. So let us try to reason from scratch. When humans read words, we try to connect them to meanings and experiences. For instance, if I say the word sunset to you right now, you perhaps might imagine the orange sky, maybe the sound of birds, maybe a memory. When LLMs read such words, for example, the sunset, they try to connect them only to patterns of what came before in the training data. Let me explain what I mean by this. So when you say sunset, they don't see a sunset. They just know that the word sunset, based on the historical data that they are trained on, it's often followed by in the West. So sunset is often followed by in the West, based on what I have seen in the past in the data. So this is the gist of how they essentially predict the next word and generate the next word. So to summarize, how do they generate the text? They take your input, they break it down into smaller pieces. And these smaller pieces, we call them tokens. Second, they look at all the data that they have seen, and then they ask, what is the most probable next word that can occur after this? They find it and they spit it out. Then they just repeat it again and again, building the whole text line, one token or one word at a time. Let's take an example. Let's say you type, the cat is on the LLM predicts mat. Now it has the cat is on the mat. Now, if you want LLM to start generating the next words in this sequence, then perhaps it could generate the most likely words. It could be and, then it, then is, then sleeping. So the cat is on the mat and it is sleeping. That's it. It generates the next word just based on probabilities, just based on math. No deeper understanding, no visualization, no experiences like humans do. So if I have to summarize whatever I said above, humans, they understand, they feel. LLMs, they predict. Now, two key terms, very, very essential in the context of all the LLMs that you'll work with. First is the context. Pretty straightforward. No sentence makes sense without the context. Example, he scored a century. Now what does this mean? Who is he? Which sport is this? What's the context essentially? So same with LLMs. The more useful context you give them, the more accurate they will generate the output for you. Second term, tokens. Now, computers don't read like us. They can't handle words as is. So they try to split whatever you enter into tokens. Tokens are essentially tiny chunks. For example, there's this big word here. So this, during the processing by the LLM, would get chopped down into super, cali, fragile, etc. Now you can think of these tokens as just Lego blocks. The AI, the LLM, they doesn't see the whole house, but the small chunks or the small bricks of the whole house. One thing to keep in mind, LLMs are only as good as their data that they are trained on. I'm assuming there are no surprises here. So basically, whatever the mathematical model that you're using is only good as the data that you train it on. If the data is biased, the outputs are bound to be biased. If the data is limited, the output will be limited. If the data is diverse and high quality, the outputs will be richer. So simply put, there is a garbage in, garbage out principle. Whatever you put in the data, you're going to get the same kind of model back. Imagine if you trained a model just on Reddit comments, the answers would be chaos. Just kidding. So let's come to the crux now. Why prompt engineering? And then we'll see what are the best practices. So first, why prompt engineering? Now, think about this. If LLMs only predict and what you can provide is only the input, then definitely you need to understand what's the best way to provide that input so that you can get the best output from that LLM. So think of prompt engineering as giving instructions to an LLM. So instead of you saying like, make me something nice to eat, you should know that you have to communicate it better. Basically, you have to engineer your query better. So instead of that, you can say, make me a pasta with tomato sauce, no cheese, and serve hot in 10 minutes. Now, you are most likely to get exactly what you want in the second prompt. That's exactly prompt engineering is. And that is why it's very, very important. It teaches you how to ask the questions in the right way, essentially turning your vague wishes into precise instructions. Now, let's try to take a look at some of the best practices that are very, very essential to keep in your arsenal when you're talking to an LLM. First, be clear and specific. Now, remember this, that AI cannot read your mind. You can say, fix my code. It's a bad prompt. Perhaps a much better prompt would be, fix the syntax error, ensure order nlog in runtime, and make it Python 3.10 compatible. So we are trying to gain more clarity with our questions and trying to be more and more specific. Second, you should give the context, but you should provide just the enough context and not overload the LLM. Now, this is where most of the people make mistakes. Definitely, without enough context, no answer would make sense, but too much of it, and be prepared to accept that model will get overwhelmed. For example, you don't want to paste 1000 lines of code. You just have to give the 20 lines around that bug. So how I like to remember and how I like to kind of feel it is, you should provide a focused context. You don't want to dilute the attention of LLM to something unnecessary. Third, break down the tasks into steps. So complex tasks are actually quite difficult to be solved even by humans. How do we communicate to a human to solve a complex task? We basically try to give step-by-step instructions to it. So nothing changes with an LLM as well. So instead of saying, fix, optimize, and test my code, you can say, step 1, fix the errors in my code. Step 2, optimize the error-free code that you got from the previous step. Step 3, add unit test to the optimized error-free code. So simple steps making up the whole complex program. So next, and quite important one, role prompting. So here, we try to assign a role to an LLM to get better answers. Examples. Scenario 1, I say to an LLM, explain blockchain. Quite generic. Scenario 2, I say to an LLM, you are a university professor. Explain blockchain to a 12-year-old using simple analogies. Essentially, you are giving a role to an LLM, and that role captures a lot of things. In the context of coding, one example could be, act as a senior Java developer reviewing my code and suggest improvements for readability and performance. So you are essentially giving an LLM a role. Different roles, different actors, and different kind of performances you can expect. Next, specify the output format. Now always try to specify in what type or in what form you want the LLM to spit out the output. Without it, it would be ambiguous for it to know. It could maybe give you paragraphs, it could give you bullet pointers, it could give you a table. So you have to explicitly specify what kind of output format you need. So instead of saying just respond with text, you can say perhaps respond with a JSON file containing keys. It also contains fixes, tests, and optimization summaries in a couple of lines. Now, next strategy, few shot prompting. Now, what is this few shot prompting? So it basically means that if you give a few examples in your prompt, they would latch onto the pattern and then continue it. Example, let's say you want the LLM to correct some grammar in your sentences. So what do? You provide a couple of examples. You say, incorrect, he go to the school. Correct, he goes to the school. Second, you provide another example, they is happy. The correct is, they are happy. Now, with these examples, you ask the question, fix, she have a car. So essentially, you are trying to provide some examples. And with those examples, it's trying to learn. It's trying to basically understand the pattern. And based on that pattern, it will then provide you the answers to your queries. That's why it's called few shot prompting. So basically, you try to show it how it's done and just don't tell it. Next, self-critiquing. Now, testing always reveals the truth. The cool part with LLM is that you can tell the LLM to critique its own answer and then improve it. Most of the time, it actually catches its own mistakes. So for example, you can say, write 5 unit tests for this function, including empty input, null values, blah, 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 whatever that prompt is. And then you can also add, critique your own answer above and also suggest one improvement. So basically, it will try to critique itself and recursively improve itself. Quite powerful. Next, try to control the length and the style. It's a well-known saying that the constraints guide creativity. Same thing applies here. If you don't specify, the model might perhaps, write an essay when you only wanted a summary. By giving length, style constraints, you force it to a tailored output. So some examples, you can say, summarize this article in exactly 3 bullet points, or perhaps explain binary search like I'm 10 years old, or write a 100-word bedtime story about a rabbit ending with a moral. So you're trying to control the specs, the configurations, the length, the style, etc. And these constraints would basically guide the LLM towards creativity. Next, iterate and refine. Now, you know that the first drafts are rarely perfect. No model would give you the best answer on the first try. The key is to iterate, tweak the wording, add details, break into steps. Think of prompts like code. Basically, you're trying to debug them until they work. Examples, iteration 1, perhaps you could write a prompt, summarize this article. Too vague. Iteration 2, you can write a prompt, summarize this article in 5 bullets under 10 words each. Much clearer. Iteration 3, summarize this article in 5 bullets under 10 words each, focusing only on the business impact. Now, you have got what you really wanted. So, refining step by step gets you exactly what you want. Prompt engineering isn't a one-shot magic. It's basically a loop of improvement that a machine and a human can work with collaboratively. Alright, so we have just covered these powerful best practices. Feel free to experiment and find even more. But keeping these fundamental ones in mind will instantly make your prompts sharper and help your AI to cooperate with you much better. Okay, so a lot of things said. Lot of the theory spoken. Let's try to now actually get a little hands-on. We'll follow this tutorial for the quick start for the GitHub Copilot. Now there are different ways that you can use the GitHub Copilot. You can use in the web browser, you can use in the IDEs like Visual Studio Code, Visual Studio, and even JetBrains IDE. You can also use that in the Windows terminal. Let us begin with the web browser first. Now, the very first step that I will do is I will go to my GitHub, I will open the account and log in. And then I will try to show you different ways that you can use the GitHub Copilot in your own GitHub. And by the way, just to make sure that you have your GitHub Copilot enabled, you can go to your profile icon at the top right. And then you can click the settings. Now you can see that there is a Copilot option here on the left menu. Click on it, features. Now scroll to the bottom. You can see that the Copilot in github.com, you can use Copilot chat in github.com. So this feature is essentially enabled, allowing us to experiment with the Copilot on github.com itself. Another way to confirm this would be in your browser, you can type github.com/copilot. You can just experiment with all the features here as well. So let's take it step by step. First, I'm going to my repository, a sample repository that I've created just for the purpose of this lesson. And let me click source, and maybe let's say this file is palindrome.javascript. Okay. Now you can see that there is an icon here. It's basically a Copilot icon. You can press here, and then you can ask all sorts of questions, all sorts of details about this file here. Pretty slick, right? The very first prompt, let me ask Copilot, can you explain this function line by line? So there you go. It tries to explain this function line by line. First, we have the counter set, initializing 2 pointers, and then it's just a standard process of checking palindrome. We have I and J, pointers moving towards each other, checking the individual characters one by one. Wherever there is a mismatch, it means that we don't have the palindrome. And there you go, we have the summary as well. This function checks if the string reads the same forwards and backwards by comparing characters from both the ends, moving towards the center. If all the pairs match, it's a palindrome, else it returns false. Pretty straightforward. Now, you might observe that this function, if I provide the input of, let's say, race car, what would this do? This would return false. Why? Because the first characters, which is capital R and small r, they would be a mismatch in the line number 4. So if we want this logic to be case insensitive, for example, race car, you know that it's actually a palindrome. So what I will do right now, I will try to make this function case insensitive. So let us ask the LLM for it. So I will say this function fails on race car test case. Can you help me make this logic case insensitive? And by the way, you can also tweak around the models here. So let's see what it says. To make the palindrome case insensitive, we should convert this to lowercase or uppercase before comparing the characters. Just pretty logical. And you might notice that it has actually spitted out to us another file, and it has done that job for us already. So it is converting all the characters of the string to lowercase and then executing the logic. So the race car, when we give input to this particular function, which is the new function, it will return true, which is expected. It gives you the options to copy the code, to even download the code in your local machine. Okay, now one more thing. We all know the importance of test-driven development. So tests are something which all of us agree are absolutely important, but somehow we just mysteriously forget before the lunch. Let's not worry now. We have the LLM. We will delegate that testing responsibility, or in other words, writing the tests, unit test for this function to LLM. LLM will do the grunt work for us. So let me show you with the help of an example in the same context of the palindrome function. Help me write unit tests for this function. Let's see what it gives out. There you go. It has created a new file again, and it's pretty smart with the naming. Is palindrome.test JavaScript, and it has provided a lot of these tests. So we have provided the brain, which is the function itself, and it has provided the brawn. Now this is pretty powerful, right? Now you can imagine if you would have written all these tests by yourself, perhaps if you would have spotted the edge case of race car and then wrote a new function to handle the case insensitivity, it would have taken at least 10 minutes. Here we have done the whole job in just 2 minutes. So essentially, with the help of Copilot, we are focusing more on the actual problem solving and less on the boilerplate and sort of cliched things. Now, we have taken a look at this example. Let's go to one more. I will go to my repository again, source, and let's take a look at the price after discount.python file. Again, we'll do the same thing. If you remember, we spotted this icon, ask Copilot about this file, and there you go. You can see that this file, price after discount.py, is attached in the context of this particular chat. So the Copilot knows what we are talking about and what context to read to give us the answers. So what do we want to ask now? Let's start with the basic question. Explain this function line by line. I don't want to spend any mental energy just understanding this. So all to Copilot. Please explain this function line by line. Looks pretty straightforward though. Okay, so what it does, takes a price, which is a float, applies a percent discount. Okay, so the discount is some percent, maybe if it's 10% of the price, it calculates the discount, and then it applies a tax rate to the discounted price. So the discounted price is price minus discount, and then we have the tax, which is provided again as an input. And then ultimately it's rounding the result to 2 decimal places. So pretty straightforward. Now let's try something different along the angles of, I would say, readability and maintainability of the code. So let's try to make this a little beautiful and aesthetic. So I will say, suggest me how can I make this function more readable, clear, and let's say in a more Pythonic way. Let's see what it says. So you can see it has given me another file, and wow, it has already added some comments about this function, arguments, what are their types. It has improved the naming. As you can see, we are being more verbose with the variable names, making it easier to read. Perfect. And it also gives you explanations. So descriptive variable names, it has added a docstring just here. Improve calculation clarity. We are using intermediate variables. Avoiding magic numbers. We are using hints. So you get the idea. Okay, next. Let me try to maybe experiment with something along the lines of performance, scalability. So let me ask, how efficient is this function? Could we optimize it to work efficiently or millions of records? Let's see what it says. So this function definitely just performs a single arithmetic operation. So it's order 1. It's already quite efficient. And let's see its notes for the scalability for millions of records. So as it is perfectly capable without any computational bottleneck, the only bottleneck for processing millions of records would be the overhead of the surrounding code and Python's inherent interpreter overhead. So this function is quite straightforward. It's like already order 1, but you can also try to ask the Copilot about various optimization techniques, various scaling techniques that you can incorporate in your business logic. So I just wanted to show you this example so that you can keep in the back of your head that sky is the limit when you're talking with Copilot. Try to get creative, try to just get more curious, knowing different nuances and aspects about the same function. Okay, enough said. Let's move to our last example. And by the way, it provides a pretty good summary at the end. So heading over to our final example. Now this time, let me show you another way to use the Copilot, which I was alluding earlier. So github.com, Copilot. And then this time, what do? You try to attach the file. So when you click attach, you can see repositories, can even upload from your computer. There is an extension. So what you do in this case, since we want to kind of experiment with our third example, you can click the repositories, click this one, or rather, let's actually try to provide the specific context, which would be the median file. Okay, this is the last one that we wanted to experiment with. So I have provided the median file as the context here. It's exactly the same thing. Instead of that little Copilot icon that you always used to see next to the file, what we are doing here is basically just opening this github.com/Copilot and then providing this file or the repository itself, if you want a broader context to give, manually using this attach. So help me explain this file, our same old good prompt, first prompt, line by line. I assume this should calculate the median based on the naming. And for your curiosity, let me also open this file on the side. Here's my file. So help me explain this file line by line. Let's see how it goes. Let's look at the summary. I like it, or the note, or this time, let's take a look at the lines itself. It has not provided summary to me for some reason, but it serves a purpose. Declares and exports a function named median. It takes in number array as the argument, sorts it, ascending order using the sort function. Then it calculates the middle index, and then it returns the value at the middle index. Pretty straightforward. That's what we expect the median logic to look like. Okay, so the next prompt. Now, this time I will keep the floor open for you. I want you all to experiment and take the drive, where you can drive using prompting. At the same time, I won't leave you without directions. I would just provide a little bit of hints, which would be the lines along which you can experiment. So first would be, you can check out for even length. So what happens, what's the behavior when the length is even? What does it return? Is it correct? Can it be improved in terms of like what's the convention to actually return the median when the length of the array is even? And by the way, all of this you can also ask the Copilot, like what are some of the edge cases where we can further improve this function. So coming back, the second would be perhaps empty nulls. How would we handle those sort of sanity checks or edge cases? Third would be along the directions of immutability. What if we don't want our input to get changed and we want it to be immutable? So think along these lines and then try to brainstorm with the Copilot. You can ask what are some of the edge cases where we can improve this, and then try to write a better function. You can write tests. You can ask Copilot about tests as well, ask about documentation, comments, etc. So sky is the limit, keeping the floor open for you guys. Before I sign off, I want to show you a couple more things that would be essential in the context of using the Copilot and to become a more power user. You can see that there are various options at the bottom. Just create an issue, sub-issues, Git, write code, README, simple calculator, Pong game, issues that are assigned to me, tell me, create a new issue, pull request. So you can experiment with all of this. I will take a look at a couple of them just to give you a feel. Okay, so Git is something that I remember the basic commands, but sometimes I forget the nuances. So let's see advanced Git commands. Explain advanced Git commands and their usage. So it's going to explain me stash, cherry pick, revert, reset. Pretty useful and out of the box. Oh, sweet. It also provides a neat summary table at the bottom. I like this. Next, I also see a create issue. Let's experiment with this. Looks pretty interesting. Create a new issue. It's using my repository, Copilot browser quick start. There you go. It has already created a draft issue for me. So let me call it initial draft issue. I can keep it the same. It's just for experiment purpose. And you can label it maybe good first issue, project. You can set it, milestone, assign it to myself, and then label maybe good first issue. Okay, so let us create this, see what happens. So it has already created this, and this issue is open now. You can also create sub-issues from this option. More capabilities below: transfer issue, duplicate issue, pin the issue, or even delete the issue. Let's head over to the repository just to double confirm. We have this repository. Let's go to the issues. There you go. We have one open issue assigned to myself, initial draft issue, good first issue that we have created. Sweet. I cannot be more amazed at the power of AI these days. If this is a human programmer, I definitely owe him a coffee. Okay, heading over to our Copilot again. Let's go here. We have experimented with this, right? Maybe let's see this since we have already taken a look at create issue. So issues assigned to me. It should spit out this unable to retrieve the open issues due to a temporary issue with GitHub API. Okay, I think there was some transient issue with the GitHub API. Let me try again, okay? Okay, so I have tried this multiple times and it works now. I think there was some transient issue with GitHub Copilot. So I have listed the open issues and the issue that we created, the draft issue, it has spit out for me. Similarly, we can see our open pull requests. There aren't any, but you can experiment with it. Summarize my latest pull request. Pretty awesome. So next, let us try to explore this feature, write code. This looks pretty interesting. Okay, so Pong game. Make a Pong game. Create a simple Pong game using HTML, CSS, JavaScript. Player should control the left paddle with their mouse, arrow keys up and down. Okay, so these are the ready-made templates that basically the Copilot has already provided in the options. And it also contains the prompts. But you can write similar prompts and it should generate, similar output for you. So this includes a bouncing ball, scorecard, and a collision detection for paddles and walls. Wow, it's not that straightforward. It's actually a little bit complex. So we have got 3 files: index.html, style.css, and pong.javascript. So the index here is the skeleton. The style.css is the look and feel, the aesthetics. And the pong is the brain, where the business logic for the game resides. You can see scores, controls, mouse paddle control, key paddle control, drawing, rectangles, balls on the screen, draw function. So pretty thorough business logic. And it has accomplished this within a matter of minutes. Not even minutes, I think seconds. So let's preview this. Oh, wow. So we have this Pong game. And I'm pretty bad at it or good at it, I don't know. But it was quite efficient in terms of generating the UI, the business logic, the aesthetics, which are not that bad. Anyways, we have explored a lot of features, a lot of Copilot features in this video, from explaining the code line by line, to spotting out the edge cases, to writing the unit tests, to even refactoring the code, understanding about its performance, scalability, optimization, and even making this cool Pong game, which I like very much here, from scratch in just seconds. So I hope I have kind of given you enough breadth, depth, as well as inspiration to just experiment with GitHub Copilot on the browser on your own. So in this video, we will be taking a look at quick setup for the GitHub Copilot, but for a different ID, which is JetBrains ID. So we will take a look at the installation in IntelliJ IDEA. I already have my IntelliJ installed in my personal machine, but if you want to install, you can just type in IntelliJ install for MacBook Pro. I am using MacBook here, but if you're using any other operating system, you can install correspondingly for that. So I'm going to skip the installation of the IDE, but I'm using this IntelliJ IDE, and this is my IntelliJ IDE that I've installed. Let me open that up really quick. And by the way, these instructions are very, very similar to the ones we looked in the last video for the Visual Studio Code. So let me open the IntelliJ IDE now and show you all these instructions in action. I've opened this IntelliJ IDE, and now what I'm going to do is hover over to the plugins, and then I'm going to search, similar to the last video that we did for GitHub Copilot. My bad, I should have done that in Marketplace. So you go to the Marketplace and then search for GitHub Copilot, and then click install. So this is the GitHub Copilot extension that will power the AI capabilities, the conversational capabilities in our IntelliJ IDE. Now it prompts me to restart the IDE. I'm going to hit restart, giving it some time to restart. So this has restarted. The next thing that I'm going to do is I'm going to create a new project. Let's call it GitHub Copilot Demo. And then you can just keep the defaults. They're good for now. And you can click create. Now this is my new project. Now you can see that at the very bottom, and let me try to maximize this. So you can see that at the very bottom, there is a GitHub Copilot icon, but it prompts us with an error saying that you are not signed into GitHub. Now, if you might recall from our last video, there are two prereqs that we always need in order to use the GitHub Copilot. You'll need a personal GitHub account with an access to GitHub Copilot plan. So I already have personal GitHub account on the profile, but the Copilot, you can see you have a personal account here, and you are also having access to a GitHub Copilot free plan. So I have the prereqs sorted. What I need to do right now is just go over here and then click on login to GitHub. And then it prompts us that we need to copy this code and open it so that we can authorize and give the respective permissions for this ID to use the GitHub Copilot account. I'm going to hit continue. I'm going to hit paste because it has already copied that to my clipboard. Hit continue and then authorize GitHub Copilot ID plugin. Sweet. So we are all set here. Now let's head over back to our ID. Or let me try to actually minimize this really quick. Minimizing this. And then you can see that there is a GitHub Copilot with a prompt saying it has successfully logged in to GitHub for GitHub Copilot. Awesome. Let's click on this and then you can see the status as ready. Now this is the confirmation that everything has been installed successfully and we are ready to move towards the utilization. I'm going to play around a little bit, and don't worry, we'll have a separate devoted video to explore all the features. But just for a quick start, let's play around with one example. By the way, you can notice that you can see this GitHub Copilot chat icon here. Once you open it, it's very similar conversational feel that we get in our modern LLMs. You can select the model, can change the mode, just ask, agentic mode, edit. Let's just keep it ask for now. And let us try to get some prompt in the context of this main class. So what I'm going to say is, can you help me write a function that checks whether a string is a palindrome? And there you go. Here's a simple function checking a string if it's a palindrome, comparing characters at both the ends. You can copy it, you can also paste it here. And then you can, of course, just test it by calling from the main function. So we have got the GitHub Copilot extension successfully installed in our IntelliJ IDE. Now, feel free to experiment with the features and just get ready to rock and roll. In this one, we will try to install and do a quick setup for the GitHub Copilot, but on Visual Studio Code. Now note that the instructions for using the Copilot, they differ depending on where you are using it. So you might recall in last video, we have quick setup the GitHub Copilot in the web browser. So these instructions are going to be a little different. I promise they are not that complex and we will take them step by step. So the first and the foremost, now before you are using GitHub Copilot in your Visual Studio Code IDE, you have to make sure you have two prereqs that are sorted out. First is you need to have a personal GitHub account. And second, whatever that account is, it needs to have an access to the Copilot plan. Let us go to our GitHub and make sure we are firm with these two requirements. So I am on my account, it's a personal account, and I go to my Copilot or your Copilot, and then I see a GitHub Copilot free. So I do have a personal account and I have a GitHub Copilot free plan. Now let us get this out of the way. The very next step, let us try to open our favorite IDE, which is Visual Studio Code. So I'm going to open Visual Studio Code here. The next step that you have to do is hover over to this extensions icon at the bottom left, and then you have to search GitHub Copilot. You see the first extension here? Just click on it. Your AI pair programmer, 48.5 million downloads. And one more thing to notice here is that if you go to the extension pack, you can see that there are actually two extensions that would be installed as a part of this package. One would be the GitHub Copilot and another one would be the GitHub Copilot chat. Now, what is the difference between them? The first extension, which is the GitHub Copilot, is basically a helper to you when you're actually writing the code. Now, what do I mean by this? Let's say you're writing the code and you need inline suggestions. Right where your cursor is. If you need any suggestion to, let's say, autocomplete the remaining function, maybe edit a little bit, then this is where it comes into picture. On the other hand, the GitHub Copilot chat, as the name says, chat is basically a conversational AI assistant. It's basically a chat window that you can talk to about your code. You can ask to refine your code, perhaps add unit test, edge cases, help you explain line by line. So these together would be installed as a part of this installation. So let us hit install here and just wait for it to get installed. It has already installed. Now we have the GitHub Copilot extensions in our IDE. The next step, you remember I said we need to have a GitHub account and then access to a GitHub Copilot plan. So what I'm going to do is just sign into my GitHub account. You can take a look at this accounts icon at the bottom here and then click on sign in with GitHub to use GitHub Copilot. Okay. We are going to authorize Visual Studio Code to access our GitHub Copilot account. Click continue. Just click authorize Visual Studio Code. There you go. You can open Visual Studio Code. Now, there is a difference that you can see is we have this Copilot icon at the top here. So you can open your chat. You can basically start talking to the Copilot. And one more thing, you can see another Copilot icon at the bottom right. So this basically completes the installation of GitHub Copilot in our Visual Studio IDE, and you are ready to rock and roll. We will take a look at many powerful features and functionalities later, but right now let us try to complete some quick setups in another IDE. So far, we have been using the GitHub Copilot free, which is good for getting started and kind of experimenting. But if we truly want to leverage the power of AI of GitHub Copilot, then it's a must that we upgrade it to at least the GitHub Copilot Pro. We get a ton of features with the GitHub Copilot Pro plan. The most valuable amongst them, which I like, is the GitHub Copilot agent. With the help of this agent, it can help you fully automate tasks in your developer workflow, enhancing your productivity. No need to write the boilerplate pull request content description. It can just handle it for you. And after all, this course is about vibe coding, which is essentially building the projects by pairing up with the Copilot. So why not just leverage it to the best extent possible? So in this video, let us talk about the exact steps that we need to upgrade the GitHub Copilot from the free to the pro. It's a pretty straightforward process, but let me show you that in action so that you can follow step by step. The very first step, we need to open our GitHub account. So I'm going to open Google Chrome and then click github.com. My account is already open. The next step that I do is hover over to my profile icon at the top right, and then I will choose settings. Inside the settings, you can see that you have under the access tab, you have the billing and licensing. And then if you click overview here, you can see which subscription you have currently subscribed to. So right now we are using the Copilot free plan, which is $0 per month. Now, in order to upgrade the Copilot free to the Copilot Pro, we have to click the Manage Subscriptions link here. Now here you can see that the GitHub Copilot, your AI pair programmer, the active subscription is free. By the way, it also prompts you about the documentation in case you're curious to know more about the details. Now we have already covered this on a super high level in our GitHub Copilot plans video, so I would highly encourage to check that out. Now since I have already made up my mind, I'm just going to upgrade the Copilot here. It's going to take me to the github.com features Copilot plans, and then for individuals, and then you can see the Pro, which is $10 per month. But the good news is we can try it for free for 30 days. Awesome. So the features here is everything in free plus the unlimited agent mode and chats with GPT-5 Mini, unlimited code completions, access to code review, Claude Sonnet 4, GPT-5, bunch of good models, 6x more premium requests than Copilot free to use the latest models with an option to buy more. And then something that I really love, coding agent. So let's click on this button, try for 30 days free. Now it's going to ask you for some of your billing information and payment information. So after you have entered that, you can just click on activate now. And don't worry, it's going to charge you after a month. So you can just explore it for a month, get a feel of it, and then you can cancel it later if there is a need to. So I click on activate now. Boom. And there you go. I have my 30-day Copilot Pro trial, which is active now. Congratulations on making it so far. You can also see on the left that we have the Agents tab here. And then you can just delegate tasks to the GitHub Copilot coding agent to work in the background and then sort of monitor the Copilot's progress. In this video, let us start making the preparation so that we can create our awesome Flappy Bird game for the web browser. Now, this video would primarily be helping you to kind of do the basic setup or the prereqs so that you are in a good shape to start experimenting and we can move gradually towards our Flappy Bird game. So with that being said, let us get started. The very first step that you need is make sure you have the Visual Studio Code installed. I'm going to be using this editor throughout this lecture to create this game. And in case you don't have it installed, it's pretty straightforward. Just go to Google, search for Visual Studio Code for your operating system, which could be Mac, Windows, Linux, whatever. It's pretty straightforward process. Now, once we have the Visual Studio Code installed, we will be opening up the terminal and then checking the version of the NPM that we have in our machine. Now, in this tutorial, we will be creating this Flappy Bird game using the React framework of JavaScript. So which is why we need to work with Node Package Manager, Node, so that we can nicely create this project. And if in case you don't have this Node and NPM installed, then what you can do is you can go to the link, which is nodejs.org/downloads. So let me open that up here so that you can see. So we have the browser here and the nodejs.org/en/download. Now here you can see based on your operating system and your architecture, you can get the installer. For me, it is macOS and ARM64, so I'm going to hit it. But I already have it installed. And once you have it installed, just make sure that you can check the versions, which we did with this command. And just a quick kind of segue, since we are basically teaching vibe coding, there is a quick little awesome feature which I want to show. So in the terminal, it's quite common that sometimes we forget the terminal commands. It happens with me a lot. So you go to the Copilot and then you click on terminal inline chat. Okay. Now let me ask, tell me the command to check the version of NPM. Now this is going to spit out npm/v, the same that we ran. And then you can actually also execute it by clicking on this run. Pretty awesome. So this makes sure we have the npm installed. Similarly, we have the node installed and we are good to go now. The next step, we are going to run this command, which is npm create void @latest. Don't worry if it looks gibberish to you. I'm going to explain word by word what this means, giving the name of the project. Let me call it Flappy Bird, and then providing React as the template. Now, what is this? So first, let us take word by word. npm. npm is basically the node package manager. So this is something that is used to install the necessary dependencies that you need for your project. So let's say you need a dependency maybe for creating modern UI, or you need a dependency for something else, maybe some database related. So for all those dependencies, you're going to use this node package manager and then give the name of the dependency. So here what we are saying is, hey, node package manager, can you use the latest version of the create void dependency? So the create void dependency is basically something that helps you to scaffold the projects. So when I say scaffold the projects, I mean that it helps you to quickly set up those projects. So you don't have to code things from the scratch. That's what I mean. Whenever you are going to use this create void and then provide the project name, it's already going to populate some boilerplate out of the box business logic on like a initial app, and then you can play around with that app and then you can slowly customize it, improvise it to reach towards your desired app. So I'm going to show all of this in action, but effectively till this point what we are saying is, hey, node package manager, please use the latest version of the create void dependency and create a project that is called as Flappy Bird. So basically this will be creating a folder Flappy Bird, and all our project related dependencies, files, folders, code will be hosted inside this folder. Next, it also tells to use the React framework in this particular project. So I hope it makes sense. If I have to summarize again, we are saying, hey npm, please use the latest version of create void, create a project called as Flappy Bird, and then use the React framework in it. That's it. Let us hit enter. Awesome. There you go. We have scaffolded the project here. Don't worry about this name scaffold if it's confusing. Effectively, what we have done is we have set up some initial boilerplate code in this particular location, and sweet, we have completed and accomplished this successfully. Now let me go into this folder with the help of change directory command, and then let me run the list command. Now you can see a bunch of files that have been created already by running this command. Let us try to take a look what these files are on a very high level. Now first let us begin with index.html. Now this is the index file that is loaded up as soon as you hit the URL in your browser. So you remember from our demo video that we are going to be creating this particular Flappy Bird application in the web browser. So whenever you hit the Flappy Bird URL, which is the local host that you saw in that video, it would be essentially serving this index.html file. Next, we have the package.json. This contains all the necessary dependencies that our project relies on. Next, we have the public folder. Now, this public folder is something that is used to store the static assets of your project. When I say static, I mean like images, icons, logos, something that doesn't change over a time. So you can store all of those in this public folder. README is pretty obvious. You can write the documentation about your project here. Source is to store the source code, the business logic of your app. We also have the white.config.js. This is used to store the configuration for the white framework. And then we also have lastly this something called as eslint.config.js. Now this is just used to store some of the clean coding things and then the best practices to make sure that our project is adhering to quality code standards. It's not critical so as to say, but something that helps us to keep our code clean throughout the project. Now, all of us are visual persons, so let me actually open this particular folder and we have it created inside my home directory. I'm going to hit open and boom, we have all these files, all these folders that have been created. Since this is an initial boilerplate that is already provided by the white, let us try to see and run this and see how it looks so that we know what's our initial starting point and then slowly kind of customize it towards our target, which is the Flappy Bird game. So before that, let's go to the terminal and make sure we have all the necessary dependencies installed. So npm install, what it is going to do is take a look at all the dependencies that are in package.json and install that. And after that, we can actually run the server. So npm install, taking some time, bunch of dependencies. There you go. So we have added 152 packages, and the next step, we are good to go to run the server. So you can hit npm run and dev. Sweet. So we have got the server running at our local host, port 5173. Let us check how it looks. I'm gonna hit this URL here. Awesome. It's a pretty good starting point. So we have this white logo here, the React logo here. I assume these are the anchors to the respective websites, and they definitely are. Just the React and the white. Awesome. And then we have something called as count here. Interesting. So if I click here, it's gonna just increment the count. It's a good initial starting point, but pretty bare bones. Then it says to edit the source app.jsx and then save it to test HMR. And then we have click on the white and the React logos to learn more. Okay. Now HMR. Now what is HMR? It's a good segue to explain this technology. So HMR effectively stands for hot module replacement. Now what does this mean? Now practically you can think of it like we are developers, we continuously update our business logic based on the product requirements. So let's say if you have decided to update any part or any piece of your code for the scope of this particular project, initial project, let's say if you are updating the counter to increment by 2 instead of 1. Let's say I actually do that just to show you. I believe the counter would be somewhere the app.jsx, and this is the part where it increments by 1. And don't worry, we will be covering all of this in detail in the next lectures. But just for the purpose of understanding the HMR, let me change this from 1 to 2 and then hit save. Okay. Now, if I go to the website and then I hit counter is 10 already, if I hit this again, it's going to increment by 2, not 1. How did this happen? The part of the code that we have changed is reflected already in our website without any refresh. Now, this is exactly what the HMR is used for. What it does is whatever you change, whatever kind of module you change, it's going to hot reload that module without refreshing the whole page, without reloading everything. It's just going to reload that particular module instantly. That's why it's called hot. And that is why it makes your life very easy as a developer when you are continuously iterating, improving things, and you have to test very efficiently on the fly. So this is what HMR is. If you want to read more about this, you can go over to this white page, which is already open here. By the way, white is again an awesome, powerful front-end framework that helps you to create modern, as they call the next generation of the web applications. So it's pretty powerful. We'll be exploring this throughout this lecture as well. And this is leveraging this lightning fast, this instant, this hot HMR, which is hot module replacement. So this is what essentially I wanted to cover in this video mainly. And we are kind of at a great point. Congratulations on making it so far. If you have any questions, feel free to paste them in the comments, in the Q&A. We'll be happy to help. But till now, we have set up all the basic things that we need for our project. Next, we will try to explore all this code. What does this do? How does this relate to our app that is being shown? And then kind of slowly tweak it to move towards our Flappy Bird game. And don't worry, we'll be using AI a lot. There's already a chat open here waiting for me to prompt something. We will be exploring all the features, ask, edit, agent, whatnot. So in this video, what we will do, you might recall in the last one that we have set up a starter project, and this is how it sort of translates. So what I'm thinking right now is let us try to understand all of these files, which serves as a good starting point, and understand their key logic, how things are hooked up together, and how ultimately all of this is being showcased here. So let's take it step by step. First, you might see that we have the index.html file. Now let's start from this very fundamental index.html file. As soon as you load this URL of the web app in the browser, what is served to you is essentially the index file. Now you can also see that in the inspect element. So let's say if I hit refresh, we have got this head and then the body. So basically our index page loaded up. Now this is the same index index.html file that we see here. So it has got head, and then inside the body, we basically create a div element of root and then try to embed this script, which is the main.jsx script, into this root div element. And then everything would follow on from this point. So essentially for the index, you can see that we are setting the char set, we are setting the viewport, we are setting the title to be white plus React. So if you go here, the same things, the char set, the viewport, the image, the title, and then inside the body, all of this is loaded up from our React app. So we will cover this one by one, but effectively inside this root, this script, which is main.jsx, has ran, and it has populated with all these elements. So let's take a look at the head first. You can see that in the head, we are basically trying to give this title, which is white plus React, that is popping up here. There is an SVG icon as well, which is loaded from this tag link icon, which is of type SVG. And then we give the address to it, just /white.svg. You can see that you can find this address in our public assets that we were talking about earlier. So this is basically the image, the title, and then we have something called as viewport. Now, this is to make sure that your app looks correctly and in right sizes and proportions on different devices. So whatever the device is, we try to give the width as the same. So width is equal to the device width, and then we scale it to 100%, not too zoomed in, not too zoomed out. So this makes sure that whenever you are using different devices, let's say tablet or maybe mobile phones, then this web app is displayed correctly there and in right proportions. Then we have the char set as UTF-8, pretty standard. It covers pretty much all the languages and all the emojis. And then next we have the body section. Inside the body section, we create a div element root and then try to run this script main.jsx. Now let us go to the main.jsx and see what does that entail. Now it's a pretty light logic here. We are importing some dependencies at the top. We are importing the strict mode from React. I will explain what the strict mode is in a while. We are importing create root. We are importing the app from the app.jsx. Now this is the app.jsx. We are exporting the app here. This is essentially our whole React app that contains the counter, the text that we see on the website, as well as the two different logos that we saw for the white as well as for the React. So essentially this whole React app we are exporting, we are getting the access to that by importing in the main.jsx, and then whatever app we are importing, we are using this from line number 7 to line number 10. So essentially what we are doing is grabbing the element by the ID, which is the root. So if you remember inside the index.html, we have created a div ID of root. So we grab that ID and then we try to render this React app that we have created here with all this logic. And then we try to embed this in a strict mode. Now, what is a strict mode? Now, the strict mode is sort of, you can think of it like a teacher mode, okay? What this does is, whenever as a developer you're writing code, this would make sure that you are not doing things that you're not supposed to do. For example, it might be possible that you're using deprecated packages, maybe some old unsafe libraries. So this strict mode will make sure and will give you a warning in case you are unintentionally doing that. Also, it helps you catch hidden side effects. So let's say if your code accidentally makes the network request every time it renders, then this strict mode is going to catch that and it's going to give you a warning about it. So it basically catches any older, deprecated, unsafe libraries or dependencies. It also helps you to kind of spot those ugly side effects. Overall, it pushes you as a developer to write clean, bug-free code that adheres to the modern React standards. Also, this strict modes only runs during development and not production. So it's basically a way of saying that, hey, I'm going to keep an eye out on your code only when you're building this project. So our users, our customers will never see it. All right, so we have covered this one. Now this is referencing the app. So let's head over to the app, which is app.jsx, hosting our main business logic. Let's see how this file works. What are some of the things that are defined here? This time, instead of me explaining, let's play around with the AI because this is what the course is about. And we are going to get a detailed explanation using our GitHub Copilot chat. You can see here that in order to add the context, you have to precede by a hash. And then for the extensions, you can add @ and for the commands /. So let's try to understand this context part here now. We know that the context is app.jsx. So I'm going to press hash and then app.jsx. And I'm going to request, can you please help me explain this file line by line. Let's see what it says. And also we have the ask mode here. So let me resize this a bit so that you can see better. Now it has added some comments for you to understand. The first line imports the use state from React. So use state hook we are getting from React, and this lets us add state to our component. Now you can see the usage of this use state in our counter that we are seeing on the website here. Now another, we have this React logo that we are importing from the React SVG in the assets, which is here. And we are getting the white logo from our public assets. Now all of these logos, they are being displayed here that you can see on the website, which is this logo and this logo. And then we are importing the CSS file for this app from app.css. Here comes our main business logic. Now this has explained the dependencies very well, but let us actually ask this to explain the business logic of this function app. Actually, if you notice, it has already done that, though on a super high level. So it has added some comments. So you can understand that this div element, and then we are placing an image inside our link, which is the A or the anchor. So basically we have got this white image here, and if you click here, it's going to open the website. So this is what is essentially being written here. We have this white logo as the image, and then we are assigning this style to it from logo. And you can see in the app.css that we have the stylings for the logo here. So based on that, it's assigning the styles. And then we also are providing an alternate text. So in case our image, let's say if it doesn't load up, so this is going to show this white logo alternate text as a placeholder. Then we have got this link, which is taking us to the respective website. And then this target, which is underscore blank. What does this signify? I know the answer, but let us actually try to ask. So @blank in a href tag, what does that mean? So this says that when the link is clicked, it will open in a new browser tab. So this is how awesome our conversational AI assistant is. You can just go deeper and deeper and try to peel the layers one at a time until you understand the complete code. It's a very good companion if you want to get a good understanding faster. So essentially this blank, whenever you open this, it's going to open in a new tab. Very similar to this, we have got another image for the React. If you click on it, it's going to open the React website. Pretty much the same logic as above, but we are loading different images and we are using a different style guide. And of course, the different alternate text. Now this comprises this div element. Inside this div element, we have got these two A tags. You can also go to our inspect element and then see inside this root div, we have got a div and then these two A tags. Next, we have got this heading, which is white plus React, just white plus React as the heading here. And then next, we have got the button that when clicked increases the count by 2 and displays the correct count. So this is pretty obvious. We are creating another div element called card. And then inside this div element, we are placing this button and we are placing this paragraph, which is basically an instructional text about editing the file, as the Copilot says, to test the HMR or the hot module replacement feature. Now, if you go to our index page, you can see that this count is being incremented. The same thing translates here. We have got the button inside the same div of card. And we have also got this paragraph, which kind of details about editing and then saving to test things on the fly. Last but not the least, we have got this paragraph to read the docs. It's just a paragraph, just a line at the end. It says, click on the white and the React logos to learn more. So all of these things, this is how they're translating here. We have learned how to understand files faster and more quicker with providing context to the Copilot, which is like hashtag and the file. You can add multiple files as context and just trying to get the lay of the land for how the things look. Now, this is very important because you can, of course, talk to the AI and you can get the information pretty quick. It provides you a lot of information, but it's very, very important that you actually understand and assimilate that information. We don't want to delegate all the things to AI and just take care of nothing because it does make mistakes. You want to kind of use it as your best pair programmer that is filled up with a lot of knowledge, filled up with a lot of information, and you extract the important things and then you kind of play your part as well to make beautiful and awesome apps. Now this app.css is just a file that contains the stylings for different elements, logo hover, root, you can see card, read the docs. So pretty straightforward, just a CSS file. I think that's pretty much it. Index.css file is a global styling sheet that we are using in the context of our entire application. Now, this is on a super high level that I wanted to give you a feel of. Feel free to experiment, feel free to go deeper into things. Perhaps I'll leave you with the food for thought. You can try to use the same exact context feature, but maybe for all of these files, and just try to experiment with what it tells, what kind of level it details, and try to go deeper, peeling the layers one by one. Happy learning, folks. Stay tuned for the next one. So in this video, we are going to take our project that we have scaffolded with white and then connect it to the GitHub. And then, of course, we are going to explore the awesome functionality, which is the agents. So we are going to use the GitHub Copilot agent to actually create our first pull request for us in a completely automated way. I'm sure you'll be surprised and fascinated with it. Now, first, you will learn how you can initialize your repository with Git. Secondly, you will learn how you can connect your local repository to a GitHub repository. And thirdly, we are going to use Copilot agents to send the PR in an automated fashion. And alongside the way, we are going to explore a lot of GitHub Copilot functionalities, features, and some tips and tricks. So with that being said, let us get started. Now, one thing to keep in mind, our agentic mode or our GitHub Copilot agent only works when the repository is actually stored on GitHub. Once we have sorted that out, the agent mode can come into picture, can create pull request, can review the pull request, and whatnot. So let us try to sort those prereqs first. So I'm going to head towards the terminal in my project and then just type git status. Now you can see that this is not a Git repository. So first we have to actually make this as a Git repository. So let's do that. But how can we do that? Well, I'm not going to Google this time because there is already a cool feature here. So if you right click, go to Copilot and then open the terminal inline chat. Now let us give the same ask to our LLM. Tell me the command to initialize this repository to a Git repository. Let's see what it says. And there you go, Git init. So I'm going to run this command and boom, we have initialized an empty Git repository in our Flappy Bird project. Awesome. You just clear things up a bit because I like this way. Now, just to double confirm, you can type git status and there you go. We are on the branch main and we have the following things that are untracked as of now. Now, the next step, I am going to the github.com and create a corresponding repository there. And then once I've done that, I'm going to link this local repository to our GitHub repository. So let me open my browser and then go to GitHub. Then you can go to your dashboard, create new repository, and then let us give a name to it. Let me call Flappy Bird Vibe with Vibe coding. It's like a good name. I'm just going to keep the description the same. Maybe a Flappy Bird game created with Vibe coding and React. We can keep it public. Now, for these options, which is to add the README as well as add the git ignore, you can see in our Visual Studio Code that we already have a README and then we already have a git ignore, just created by the initialization command that we have ran. So I'm going to skip these, no git ignore, let this be turned off, and then you're just going to create the repository. It's just going to take a second. Now we have got the link for this GitHub repository, which is github.com, sweetcody, Flappy Bird with vibecoding.git. I'm just going to copy this and then head back to my terminal in the Visual Studio Code. Just going to clear this up. Now, let me try to link our local repository to our GitHub repository. So I'm going to right click again and then open the terminal inline chat and then ask the Copilot for the command. So tell me the command to link the local GitHub repo to a GitHub repo. Okay, so it says git remote add origin, and then you specify the GitHub repo URL. So this is the same URL that we have copied from the browser after creating the GitHub repository. I am just going to copy this. I'm not going to run this because we still have to specify this GitHub repo URL. So I've copied this. There is an icon here which you can use to just close this, add this, and since I have copied another thing, I would have to recopy my link, which is this one. So let me copy this back and then let's paste this here. Awesome. Now it seems to work, but how can we check this? Let's ask Copilot again. So right click, terminal inline chat. Okay, so tell me a command that helps me check if the remote has been successfully set up for my local repository. Awesome. It says git remote v. So let's run this command and there we go. So we have the origin, which is successfully set up for fetching as well as pushing to our Flappy Bird with the Vibe coding Git repository. Wonderful. So now I am going to make my first commit. So I'm going to say status. Okay, these are the files that we need to add. So git add all of them. Now you can still ask the Copilot about these commands, but I remember them, so I'm just using them right away. But I hope you get the gist of it. And then next you can do is git commit. And let me call this initial scaffolded project with white and React. Seems like a good name. We have committed and let us now push. Let's check the branch I'm on. I'm on main. That's correct. Let us now push this manually using the git command. Now, once we have pushed this manually to our GitHub, and then we have a proper GitHub repository created, after that, we can start using the agents. So let us complete this step now. So I'm going to, again, ask my Copilot, write me a command to push my local main branch changes to the origin. So it says git push origin main. So let us try that. So let me copy this and then paste this here. Oops. Anyways, I remember the command. So it was git push origin main. Now I am going to add one more tag, which is u. And this u basically means upstream. So what we are doing is we are setting a default tracking relationship between our local main branch and our GitHub's or remote main branch. So we don't have to do it again and again. So git push u origin main, let's press enter, and boom, we have pushed the changes to our main. Now let's check on our GitHub repository that we have created if these changes are being reflected. Going over to my GitHub, refreshing this. Awesome. We have got those changes. We have got the recent commit. Wonderful. Congratulations on making it so far. Now stay tuned. In the next one, we are going to leverage our Copilot agent to actually create these PRs, these changes in a completely automated way for us. So in the previous video, we have seen how did we initialize the GitHub repository and then also created an online GitHub repository and tried to link the local to the online. Now that was all done for the purpose so that we can actually start using the Copilot agent to send more PRs for us, but now in a fully automated fashion. So with that being said, let us get started. Now first, what I'm going to do is I'm going to make a tiny change in my code base so that the Copilot can then pick up that commit and then send a PR for us on our behalf. So before that, let us make a new branch. Let me call it as, or maybe let us actually ask the Copilot terminal inline chat support, which I really like. Create a new branch and check out that branch with a name. What should I name it? Maybe we call Flappy Bird Demo, just a demo branch. Wonderful. Let me run this. So we have switched to a new branch. Let me quickly double check it. And I am in the new branch. Now the changes. What changes should we do? Maybe let's go to the app.jsx, which is open right here. And let's make a small tweak in the heading. Okay. So right now it is white plus React. What I'm going to say is get ready to build Flappy Bird game. Awesome. Hit save and then check the status. We do have the app.jsx modified. The next step, let's commit these changes. So git add in the staging area. Again, check to make sure this is green. We have staged it. And then commit, just like changing the heading to Flappy Bird game and then hit enter. Awesome. So we have these changes that are in the new branch, which is Flappy Bird demo built on top of the main. Wonderful. The next step, let us get started to using the Copilot agent. In order to talk to the Copilot agent, it's pretty simple. You see an icon here, just click here and then open the chat. And then you can write a prompt for it. You can basically say, making sure that we have the agent mode here, which is extremely important because there are 3 modes, which is ask, which we were using before, edit, we'll explore it later, don't worry, and then the agent mode for the agentic operations. So you toggle over to the agent mode and then you write a prompt. Can you create a pull request for me for my latest committed changes in my current branch, which is the Flappy Bird demo. Let's see what it says now. Okay, it says to me that there are no uncommitted changes in my current branch, which is true because I have already committed the changes. Now, since all the changes are already committed, I can create a pull request from the Flappy Bird demo to the default branch main, which is what exactly I want. Would you like me to proceed with creating a pull request for all the committed changes? If so, please provide a title and description for the pull request, or let me know to use a default message. So I would say you can use any sensible title and description detailing the PR. Now let's see what it says. Okay, now it was saying to me that you can actually run this command in the terminal. So I tried to explicitly detail that if the agent can itself create the PR for me, not asking me to run this command. So it says to me, start coding agent. It also says to me that the coding agent will continue working on adding the latest Flappy Bird improvements in a new branch, and any uncommitted changes will be automatically pushed. So let me hit continue for now and see what it does. It says launching the coding agent. Now, interestingly enough, it says to me that it attempted to create the PR automatically, but there was an error due to the missing user authentications or permissions. And in order to resolve this, you may need to sign into GitHub. Well, I am actually already signed into my GitHub in my VS Code. Let me actually quickly check my repository. Wonderful. So we do have the PR that is created. So if you see this Flappy Bird demo, and then compare and pull request, we do have these changes. Awesome. So I think it's a glitch. It might also happen to you because of failing to get the permissions. If that happens to you, just make sure you have already the PR created. If it's created, then you're set. If not, make sure that you can sign off and then sign on again. That might actually fix this. But with that being said, we do have the PR, which is created by the agent. It's right over here. Sometimes the VS Code just tries to be more cautious since it's working from the editor itself to your GitHub and related permissions. But we have the PR. We can see these changes are exactly the same that we did. And we never had to create the PR using the terminal. We just asked the agent and it did for us. Great job so far. Now, if you actually even go to your VS Code, let me open the VS Code really quick. You can see in the GitHub icon here that the coding agent has actually one pull request to view. So let's see what this is. I'm going to slide it more so that you can see it better. Now, interestingly enough, Copilot has also created another PR, which is add complete Flappy Bird game implementation authored by Copilot. And this is actually created on my behalf since we have activated this agent. Now, let me click on it and see what this is. Wow, it's already doing a bunch of things for me without even not me asking for it. So I am excited. Let's see what it has done. It has made a bunch of commits, this initial plan, and then implement the complete Flappy Bird game with all the features. Superb. And it wants to merge the changes into our Flappy Bird demo from the Sweet Coding Copilot, basically a branch that Copilot itself has created. So essentially what it is doing is, since we have activated and started the agent and then asked the agent to send this PR for us, it was smart enough to guess the purpose of these changes for us. So the changes that we made in the PR was from White plus React to get ready to build Flappy Bird game. Copilot had this context, the agent had this context, and then it was smart enough to pick it up where we want to go. And consequently, it has also created another set of changes in its own separate branch, and now it is asking us to review them, whether they fit in the scope of our purpose, whether we want to merge it in our Flappy Bird demo. That's so impressive, man. Now, let us actually see these changes. Now, this is where a human also comes into the loop. Agent was smart enough, it detected what we wanted to do, but before committing and before accepting these changes, let us actually try to view them and see how they look. So this is where I am actually trying to pair program with our Copilot, who's acting as my teammate. You can think of it, he's acting as your junior dev helper. Based on what you want to do, it has actually made those changes and now it is asking for you to review. So you can review, and then if you like it, you can just commit that. So we are going to do the same. First, let me click the checkout button. I'm going to check out these changes. Now it has done changes in a bunch of things. It has done in app CSS, JSX, Flappy Bird files. It has created new Flappy Bird files for us, as well as the index HTML. And all these changes are detailed here for you to take a look. So let me collapse them for a while just to show you them. Now, before I check all these changes and I try to compare them with my current version, what I'm going to do is I'm going to quickly check and try to run the application, because the first thing that I need to make sure is my application or my game is actually functional. And once it is functional, it gives me more detailed view of what the things are, and it makes it easier to check and verify and even tweak it if needed. So I have checked the status. I'm on my current branch. This is what we have checked out. Just for the purpose of showing you, we are on the current branch. And then the next step, so I'm going to run npm run dev. Excellent. So once I've ran the npm run dev, we have our localhost started, and let me pull up the app here really quick and you'll be amazed to see how the app looks. Boom, there you go. Isn't this impressive? Just a couple minutes and this is what it can create for us. We have the physics engine, we have the ball, we should have a bird, okay? And there are some characters which are getting messy at the top here. So we have the instructions here, which is control the bird with a space bar. Oh, I can also play with the space bar and it works perfect. Or a click to jump, and you can avoid the pipes and try to get the highest score. So seems like a pretty good starting point. There are some things to improve though. That would be this characters, also the orientation of this canvas if you look at it. So when you open the browser, it is kind of shifted towards the left. So ideally we want whatever device we play it on, maybe like we can start with a web browser, it should be towards the center and in right proportions, making it aesthetically good. And apart from that, definitely this is something that we need to take a look. Maybe we can tweak with the colors, but for now, it's a good starting point. So let's head back over to the Visual Studio Code. So back to the Visual Studio Code. Now, what I will do is, before making these enhancements, what I'm thinking is to break these enhancements separately from our bare bones game implementation. So essentially what I'm saying is, let us merge these changes first in our Flappy Bird demo. And then we can create a separate branch, maybe ask the Copilot to again create separate commits in a separate branch to fix those enhancements. And then we will merge them again into the Flappy Bird demo branch. So why am I doing this? I'm doing this because I like to break my changes into smaller parts and then iterate on them so that it becomes easier for me to recover later if there is a need to. Also, it becomes easier for a person to understand the version control and the history in order to understand your code base. So it's just a good practice. So first of all, let us try to merge whatever we have done till now in our Flappy Bird demo. Now, let me ask the Copilot about how can I do that. I will open the terminal inline chat and I will say, can you write a command to merge the Copilot fix changes into the Flappy Bird demo branch. And let's see what happens. Boom, it has given us the command. So let me try to copy this. I would have to make a little change here, which would be to spell out the name of the branch correctly. But even before that, let us check where we are right now. So I've typed git status. We are on the Copilot fix branch. Let's see our version history and the tree. So we are on the Copilot fix branch. We have two commits, which is an initial plan and the implement complete Flappy Bird game with all the features. And this is the branch where we want to merge these into. So let me hit paste, and instead of just saying Copilot, I would just copy this and paste this here. And then let me run the command. Awesome. Going to just clear my screen and then see the status. So we are on the Flappy Bird branch, and let us again make sure our history is correct. And there you go. We have all the commits done by the Copilot fix, as well as our initial commit that are lined up in this Flappy Bird demo branch. So now just as a sanity check. Let me run the server. So we have hit a good milestone. Now let's try to work towards the enhancements. Back to the Visual Studio Code. Let me also close this pull request since we have already merged using our git commands. So let me hit close pull request. And then we can perhaps also delete the branch since we won't be needing it anyways, just from a cleanup perspective. So delete the local as well as the remote branch and hit OK. Now, just to confirm this, you can go over to your GitHub and see the pull request, and you can see that this PR is closed. It was open earlier. Let's see if our branches have been successfully cleaned up. They are. We don't have any Copilot branch here. We just have a main and then a Flappy Bird demo. Now, if we look at the Flappy Bird demo and the version history, we have the changing heading and the initial scaffolded project. Now, the changes that were suggested by the Copilot, they have been merged in the Flappy Bird demo, but locally. So we also have to push these changes to the GitHub. So let's do that final step. Let me just stop the server for a while, clear the screen, hit the Git status. You can see it says to me that your branch, which is the Flappy Bird demo, it is ahead of the origin Flappy Bird demo by 2 commits. So we would have to push these changes so that our origin and our local are aligned. What I'm going to do is run our old good push command. So git push origin and then the Flappy Bird demo. Excellent. So we have pushed these changes. Let's check the status again, and it says your branch is up to date with the origin Flappy Bird demo. Now, you can also verify in our repository for the Flappy Bird demo that we have all the necessary commits till now. So that's pretty much for the scope of this video, but we do have the enhancements that we have to work on. So we will work with the Copilot agent to do all those enhancements for us in the Vibe coding field. So in the last video, we have already committed those changes to our Flappy Bird demo branch. And then we were also taking a look at the enhancements. Now, throughout this video, we will be working with the agent a lot. So we will be asking it to make those enhancements in the code base for us, create the PR, send the PR, and then we will also review those changes. We will also take a look at the HMR updates while in parallel, the Copilot agent updates the code for us. We will also try to debug the code, attach media files, snapshots, and give good prompts to the Copilot agent so that it can work the best for us. So with that being said, let us go over to the Visual Studio Code. Let me run the server really quick so that you can see the current lay of the land for the game. And I have opened this game in my browser, just right over here. So you can see a bunch of improvements that we also talked about earlier. First of all, this whole game area, this is tilted towards the left. So we can ideally center it or make it towards the center in right proportions so that it looks visually balanced. Second, I could see some messy characters at the top left here. So we can also ask to update that. And thirdly, perhaps we could give a better color combinations just from an aesthetics perspective, but I would keep the first two on priority. So let's get started. Going back to the Visual Studio Code, going to the chat, making sure we are on the agent mode, and then giving a prompt based on all of this. So essentially, we want to prompt the AI or our GitHub Copilot that it can start and activate the agent mode for us, and then use that agent, that coding agent, to make the changes for whatever enhancements that we suggest in a separate fixed branch. And then as a pair programmer working with the AI, we will try to review that branch. If we are satisfied with the changes, with the implementation, with the actual gameplay, then we can commit it to our Flappy Bird demo branch, similar to how we did in the last one. So I'm going to write a prompt based on all the enhancements that we have discussed. Now, we might have to iterate through it. In the best case, it could just catch it in the first run. So let's give a shot. So I'm going to start with saying explicitly, and this is sometimes very important, that start the Copilot agent and maybe create a new branch called as maybe feature enhancements from the Flappy Bird demo branch. And then I can say update the code base in the enhancements branch such that the game area is visually centered on the page. Currently, it is tilted towards the left. And we will also attach a snapshot, and you will say refer to the snapshot attached. So let's quickly grab the snapshot. Going to open this. Command Shift 4 if you're using Mac. Let's get the snapshot, and then we will try to attach it here. There you go. So we have also attached the snapshot and the media for the Copilot for better context. We can also say, make sure after the changes, the game area scales gracefully on all different screen sizes. And then I will just keep this ask or this announcement in this prompt. And then for the second prompt, which is the messy characters, we will take it iteratively in the next prompt. And just for me to wrap up this prompt, I will also say that commit the changes with a clear message and open the PR into the Flappy Bird demo and add me, assign me a Copilot as the reviewers. Now let us just wait and see what it does. Hit the enter. Boom, our cute little Copilot trying to be defensive and asking us to run this command. Now, I have seen this behavior quite often. It is probably because right now it is in preview and this is kind of more in the suggesting phase rather than directly executing. So just to be explicit, I would say don't just suggest any commands, but directly execute them on my behalf for my requested changes. Start the coding agent and let the agent complete all the tasks. We also add itself. Now let us see what it does. Okay, so it says to me, start the coding agent. The coding agent will continue working, enhancing the game area centering and responsiveness in a new branch on Flappy Bird with Vibe coding. Any uncommitted changes will be automatically pushed. Okay, let's hit continue. It says to me launching the coding agent. Let's wait for a while. It says to me that there was an error due to a missing user assignment. To proceed, please confirm your GitHub username and ensure you have the necessary permissions for the reviewer assignment. Once confirmed, I can retry the agent to complete all the requested tasks automatically. Okay, so let me confirm. My GitHub username is Sweet Cody. Can you please retry the agent to complete all the requested tasks for me? See what it does. Again, asking me to continue to start the coding agent. Okay, I see that there is a persistent error with the coding agent due to the missing context. But if I take a look at my GitHub, I see that it has already sent a couple of pull requests for me. Now, this is again a similar glitch that we saw with the Copilot agent when it says it cannot do the job, but it has actually done the job for us. Now, these kind of things can actually happen because right now at the time of recording this video, the Copilot is actually in preview. So it can say things like, missing user context, missing permissions, though the server-side agent has already done that job for us. As we can see that it has already created the PR. It could be that VS Code didn't get the green light, but the server-side job has already accomplished the things. The best way to confirm would be to actually do your own due diligence to confirm things manually, maybe on GitHub, maybe on the VS Code pull request tab. If the purpose has been achieved, you can just ignore these messages. And also, it takes a while for the coding agent to get started, so you have to also make sure you are giving it enough time. Excellent. I'm glad we faced this and we went through it. So we have the PRs now. Let's hover over to the PR. And interestingly, there are two PRs, which pretty much look the same, at least based on the message. They could be because we have tried this launching the coding agent a couple of times. So it has probably launched a couple PRs. That's my best guess. But maybe we can get started with the pull request too, and we can take a look what it has done for us. Now, firstly, you can see that it has created a branch, just fix, ECD, blah, 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 and then it wants to merge those changes in the Flappy Bird demo. And then it has also commented that it has begun the work on enhancing the game area centering and responsiveness and will replace this description as the work progresses. Now, you can also check that on the GitHub. So if you go to the GitHub and you take a look at the pull request, by the way, it says that there is work in progress at the moment. It means that Copilot is doing the job. You go to the development area here, and below this, you can click in progress. Now this generally shows the state of the development, basically what the agent is doing on our behalf right now. You can see that this is in progress and it has been in progress last 14 minutes. So this is why I told to be a little more patient with the Copilot agent. You can even stop this session if you want, but I'll just definitely not do it right now. Back, and then again go to the Visual Studio Code. So I have waited for a while and it seems like the pull request 3 has already been completed. Pull request 2 is still work in progress. So what we'll do is we'll take a look at the pull request 3. We'll reward it for completing its job earlier. And you can see that it has created an initial plan and then enhance the game area centering and responsiveness. So for the pull request 3, let us first try to check out this branch. So what I'm going to do is first let's close the server, clear it, and then check out. Now we have checked this branch up and let us run the npm run dev to start our server and see whether these changes have centered our Flappy Bird game. Now I see that unfortunately, our area has not centered. It is still on the left. So maybe let us ask it again. However, I do see that the characters that were a little messy at the top, they are sort of rectified a bit. So we have a score and then we have the current score. So there are some changes that are done, but we have not fixed the changes when it comes to alignment of this at the center to make it visually balanced. So let's head over to the Visual Studio and ask the Copilot agent again to make these changes. So I'm going to say to the agent, and before this, let me quickly grab the snapshot again. So opening up the local host, grabbing the snapshot here, and then attaching it, saying that I see that the latest changes in the pull request 3 still have not achieved the purpose of centering the game area. Refer to the attached snapshot. I want the game area to be centered horizontally on the screen. It should be displayed in right proportions, not too stretched and not too squished either. You can also say that you can critique your own changes and make sure it works this time. Start the coding agent, execute this task for me. Now let's see what it does. Okay. It says to me the previous changes did not fully center the game area horizontally as seen in your latest snapshot. It still remains left aligned and does not scale proportionally. To resolve this, ensure the game area container uses a flexbox. Set the max width, apply this. I will start the coding agent to execute these enhancements. So let's see what enhancements it does first. I'm going to hit continue to start the coding agent. Now it says to me that the coding agent is now executing the task to center the game area horizontally and ensure it scales proportionally. We'll update the PR3 with the necessary fixes. You will see the changes reflected in the PR once the agent completes the update. So now it's the time to wait, folks. Even if you go into our pull request 3, you can see that the Copilot has added the respective comment and it is working on these changes. So let's wait for a while. Now, as a matter of fact, even if you go to your GitHub, the corresponding pull request, and then you see the development, it has started a minute ago. Now it is actually taking a look at those changes that we suggested and is working on it. So I will just wait for a while, keeping my fingers crossed this time. Okay, so now I have given enough time to it and I can also see that it has actually committed the changes. But if I take a look at the local host and then try to bring the game over here, you can still see that there are some changes. It has been scaled good, but the game area is still towards the left. Okay, don't worry, let's try to resolve this. So now I'm going to say that you are getting it wrong. The Flappy Bird container should be fully centered in the viewport, both horizontally and vertically. I'm trying to be a little more explicit here when it comes to the technicalities. Also, I will say that refer to the screenshot attached, and then I'm going to say update the CSS so that the entire Flappy Bird container takes the full viewport height/width. The game canvas should look visually balanced and scale proportionately. It's not too stretched, too squished. And say, please fix this centering properly, understand my ask. Let's see what it does now. We missed to attach the snapshot, but it's fine. Our prompt was descriptive. Hopefully, it has already started doing the things. And actually, it has suggested me some things as well, which I can take a look here. But before I take a look at this one, let us open our local host and fingers crossed this time. Hopefully it works. And there we go. It worked for the third try. So we have our Flappy Bird game area in the center of the screen. Looks visually good, at least better than our previous version. Let's see if the gameplay functionalities are still good. They look good to me. Yeah, high score. Click or press space to start and the instructions. Wonderful. So the learning here is you might need a couple of iterations and a couple of prompts in order for the Copilot to get your ask. And you can try to be more detailed, even technically a little bit, so that it actually understands what you're asking for. But the cool thing, all of this we have done by just communicating in our conversational fashion with our Copilot agent without taking a look at the code at all. However, that's not recommended. And before we commit these changes, it's the best practice to take a look at the code. Because at the end of the day, what is happening is we as a human are trying to pair program with our Copilot. So our part, which is validation, making sure it does the right things, and its part, which is to actually do it pretty quickly and efficiently, both of them should go hand in hand for our V2 developer experience. Now, it seems good to me and it has achieved the purpose. By the way, let's get rid of this pull request too. It doesn't have any purpose right now. So what I'm going to do is go to the bottom and then close this pull request. And this is closed right now. We just have the pull request 3 that we are working with. Now, before we commit these changes, we will go through all of the changes that the Copilot has done for us, which includes essentially creating a Flappy Bird JSX and the corresponding style sheet, as well as making changes in the app.css. So let us take that in the next one. Now, if you remember, what we did was asked our Copilot agent to make the changes to center, and then it has sent out a PR with the following changes. And we were interested that before we commit these changes, let us just take a look at all the files and all the changes it has done till now. The purpose is that we should also be aware, at least on a high level, that what pieces of logic reside where in our code base, so that if we need to make any changes, we know where to go ahead and quickly make those changes, or even work with the Copilot to make those changes on our behalf. So with that being said, let us get started. Now, first, let me go over to my project structure. And then let us go to our index.html. Now this index.html is the very first thing that gets loaded up when you actually launch the game in your web browser. So let us see what it does. Now we have already understood this even when we were trying to get a hold of our starter project, that what it essentially does is just loads this main.jsx script. Inside the app, if you recall in our starter project, there was a bunch of code here. Now it has replaced that and it has loaded a Flappy Bird component here. And it has then exported the app to be used inside the main.jsx that we have seen. Now if we go to the Flappy Bird JSX, this is where primarily the whole game logic resides. Now we will take a look at this, but before this there are some CSS files too that it has created in correspondence with the Flappy Bird JSX files. Now CSS files are pretty much mainly for styling, so I'm going to skip that for now, but let us go over the main business logic of the game and just try to understand this class on a super high level. Now first, it is trying to do a bunch of imports, use state, use effect, reference, and callback. Then it defines a lot of the constants in something called as game config. Now the purpose here is that this is a one-stop shop to tune or to configure any gameplay related or canvas related constants. As you can see that it has constants for pipe width, pipe gap, pipe speed. Now these would be useful if you want to tweak the difficulty of the game. We have the gravity, the jump force, the spawn rate for the pipes. We have the bird's location, the bird size, as well as the canvas width and the canvas height. Then it defines 3 game states primarily, which is the start at the very beginning. Then if we are playing, it's the playing game state. If our bird hits any of the pipes, it will be a game over state. So there are only 3 states possible at any given instant. Now it defines our main function, which is the Flappy Bird function. Initially, it takes a couple of reference to our canvas as well as to our game loop here. Then what it does is it tries to set the game state using the useState function in React to be the start, which is at the start of the game. We set the score to 0, and then we also set our high score. Now, how do we do this? It tries to load the high score value from the local storage. So basically, the high score is persisted across the sessions. Now, next we have the very important game objects. What it does is that it stores all the dynamic elements of the game. So the position of the bird keeps on changing. There are pipes that keep on adding up, getting removed from the screen. And then we have the frame counter going on, which is frame 3rd, frame 4th, 5th, 6th, and so on. So all of this state, the dynamic pieces, are encapsulated together in something called as game objects. And one more thing to note here is that number one, we are using it as a reference. This makes sure that whenever there is a new frame loaded, we are not essentially re-rendering the whole thing, but we are just pointing to that new state. Secondly, at the start, we are keeping the position of the bird in the middle of the screen, keeping its velocity 0. There are no pipes and the frame count is 0 as of now. Next, we have the update canvas size. We'll come back to it later. We'll take a look at the jump function first. So it's again pretty straightforward. There can only be 3 possible cases when we press the jump button. First is, let's say, if we are just starting the game. If we are just starting the game, then pressing the jump and would impart some initial velocity to the bird using our jump force constant. Second, let's say we are already playing. Of course, then what we just need to do is keep our state as playing, so we don't change any of the states here, but we again impart a velocity to the bird based on our jump force. Thirdly, we have the state which is the game over. In case the person presses the jump here, all we would do is just restart the game. So put it back to the start, set the score to 0, and then again the game object state, which is the dynamic representation of our game at any point, to its initial constants. Now, moving to our check collision function. Again, it's a pretty straightforward function. If you take a look, what we are doing is basically getting the top, the bird bottom, the bird left, and the bird right. So you can think that we are trying to create an imaginary encapsulating square/rectangle around the bird, just for all the top, bottom, left, and right coordinates, and then using those coordinates to check for the collision against obstacles. So obstacles could be ground and the ceiling, which is what we are checking here. They could be pipes, which is what we are checking here. Now, if there are no collisions and we never ran into lines 92 and 99, what we do is return false, line 104. Next, we have the main game loop for this function. Now, you can think the game loop to be the main heartbeat of our game. Now, first, what we are doing is grabbing some of the things like our canvas, our context, which is the 2D context from the canvas, and then our live game objects, which is the bird and the pipes from our game objects. Next, what we are doing is clearing the canvas. Now, this is essential because whenever we load a new frame, we want to wipe out the existing frame so that these frames don't stack up on each other. So every time for the new frame, we are clearing the old canvas and then painting the canvas again with our sky blue color. Next, if we have the game state as playing, what we are doing is just updating the bird physics. So basically applying the force of gravity to the bird's velocity and then changing its Y position based on its velocity. If we in case hit a jump, then this would be reverted and the bird's velocity would be in the opposite direction. Now, next is we are spawning the pipes. You can see that in the interval of spawn rate, whenever the frame count modulo spawn rate becomes 0, we are essentially creating a new pipe towards the right side of the screen, and there is a randomness involved when we give the height to the pipe, and then we are just trying to push this created pipe to our dynamic pipes array, which we were storing in the game objects. We are giving it the top height, the X position is towards the right hand side of the screen, which is game config canvas width, and we are setting the initial scored state to be false. Next, all we are doing is updating the pipes. Now you can see in this function here that we are taking a look at all the pipes from the right to to the left. And then what we are doing is updating the X position or the horizontal position of the pipe. Basically, we are moving it left. Now, if we see that the pipe has already been off screen, we just try to remove it from the frame. And we also make sure that whenever there is a bird that crosses this particular pipe, we just set the pipe's code to be true and also update our score. Here, we are just making sure that if there is a collision, we set the game state to be game over and also update our high score and store it to our local storage. Eventually, we are just updating our frame count in the game objects by 1 because we have already processed this frame. Now, next few lines, we are just drawing couple of things on the screen, which includes the pipes. This includes the top and the bottom pipe. They are green in color. This also includes the bird, which is golden in color. And this also includes our score text, which is black in color. We are handling the resizes here based on our last prompt. We'll come to this later. Let us take a look at this one first. Now here, what we are doing is basically starting the infinite loop for our game. We are calling the request animation frame and we are requesting the frame 60 times every second. We are cleaning it up here when the component unmounts to prevent any memory leaks. Next here, we are handling our space jumps. It's listening for the keys. If the code or if the button pressed is space, then we are jumping and also preventing the default. So whenever you are playing the game and you are jumping, it would prevent some default behaviors like, for example, scrolling. It would prevent your browser scrolling up and down because the game is being focused on. And then again, we are removing the listener here when the component unmounts. Now, finally, we have the whole React Flappy Bird component, which is returned here. Now, essentially, whatever is rendered on the screen, that is being returned here. You can see things like current score, high score, the prompt to press the space to start, game over, final score, press space to restart. So essentially, whatever the face of our game is, that is being returned here. Ultimately, we are just exporting this Flappy Bird component so that it could be used as we have seen in our app.jsx. So now coming back to our commit again, and then now let us see the exact changes that the Copilot agent did for us in our latest commit when we have specifically asked it to center our game area. So primarily there are two pieces of logic that I can see getting updated in this particular Flappy Bird component. They are highlighted in green, which is the update canvas size as well as a use effect. So let us take a look at them one by one. Now first, we are grabbing our actual canvas here from the canvas reference. Some sanity checks here. Next, it takes a look at the parent element of the canvas and then gets the width of the parent element. This is so that it knows how much horizontal space is available for the canvas. It then calculates the aspect ratio from our game configs for the canvas width by canvas height. Next, it tries to pick the canvas width to fit inside the parent, but at the same time not growing bigger than the original design. Now, based on this width and the aspect ratio, we are trying to get the canvas height. Now, finally, we are trying to update the CSS size as well as set our internal resolution. Now, the CSS will dictate how it looks on the screen and the resolution will dictate that it looks with a good sharpness. If you look at the function here, what we are doing is just making sure that whenever our browser dimensions are updated, if it's resized, we are also updating the canvas accordingly. Here we are just cleaning out the listener if the component has already been unmounted. Now, if we take a look at this CSS, you can see that in the Flappy Bird container, the display flex, the justify content center, the align item center is basically centering our Flappy Bird container both horizontally and vertically on the page. If you also take a look at our game area, you can see that the display, flex, justify content center, align items center is what is making the canvas sit right in the middle of its box. Okay, so what we would be doing next is we would be merging these changes, all of these changes that the Copilot has done for us to center into our Flappy Bird branch. Before that, let me hit the status. There is one file, which is the CSS file that needs to be committed first. So let me add it to the staging area. And that commit, maybe I could give a message is update Flappy Bird CSS, so center the game, just clear it up. And then what I'm going to do is copy the name of this branch the fixed branch, and then ask the Copilot to merge it. So can you help me write a command to merge the fixed changes into a Flappy Bird demo? Says me to check out the Flappy Bird demo and then merge these fixed changes. Looks pretty good to me, so I'm just gonna hit run, and boom, it has done the job for us. Now let us just hit the status once again. We are already in the Flappy Bird demo. Let us see my history. Just git log v, and there we go. We have all the updates for our centering. Excellent. Now let me just push these changes on the GitHub. So git push origin Flappy Bird demo, and it has done the job for us. Congratulations on making it so far. We have thoroughly understood the code. We have centered our game. We have brought the game to a decent milestone. Next, we'll be doing a couple more enhancements and taking a look at some more features. Let us enhance our Flappy Bird game a bit more. Now, you might recall from the last videos that we have explored the agent functionality here, the ask functionality here. Now, in this video, we will be taking a closer look at the edit functionality from the GitHub Copilot. Now, this is also very, very powerful. Now, until now, we have sort of built the base version of the game, if I can say. Now, in this video, we will be trying to enhance a couple of things, leveraging our edit GitHub Copilot mode. So let's get started. Now, what would be our specific goal? Now, in order to understand that, let's look at the problems. So we can run the command npm run dev. We have our local host server started. Let me quickly bring the game in this window. So here you can see that we do have a current score and the score, okay? And they both are essentially keeping track of the same thing, which is our current score. So I don't think we need the score as such because both of them are giving the same information. Secondly, you can see that the high score and the current score, they are kind of overlapping with our game boundary. So we want to improve this little bit on these two fronts, just for the players to get a better, neat, polished UI. So let me head back over to the Visual Studio. You can head over to the chat, and then you can choose the edit mode. Now, before we dive deeper into the edit mode, let us briefly understand the differences between the edit, ask, and the agent modes. Now, the very first, we have the ask mode. Now, the ask mode you can understand is just like a Q&A, So you just ask the questions, you give prompts, and it is going to spit out the output just in the chat window for your questions and queries. Quite straightforward. Next comes the agent mode that we have used in the previous few lessons. Now, this agent mode is sort of a hands-free automation, if I can relate to it. The GitHub Copilot in its agent mode would basically handle bigger chunks of tasks for you on your behalf. It could include things like creating the PRs, committing the changes, creating different branches, and whatnot. So we are kind of moving towards, or I should say rather tending towards full autonomy, or precisely autonomy to a very significant extent by the GitHub Copilot. Now, edit mode comes somewhere in between the ask and the agent modes. Now here what you do is you provide context to the Copilot, which could be a particular file, bunch of files, or maybe your entire code base. And then very similar to the ask mode, you just write a prompt and then ask the Copilot to edit those files or maybe some of the respective files that it finds to achieve a specific purpose. So essentially we are just asking the Copilot to actually do those changes and edit those files on our behalf. So it's kind of our editor-in-chief. You would tell the Copilot to rewrite some changes to achieve a specific purpose. It will do it for you, but you still have to go through it and review it. And one more thing, this edit mode is useful and apt in the context of code changes. It's kind of a partial autonomy, I would say, to a moderate extent, where you still have a decent control. Enough said. Let's actually experiment. Let's use to get a better feel. That's the best way to understand. Now, our first enhancement, which is to get rid of the score from here. Okay, so let me grab a snapshot and attach this media file to the Copilot so that it has a better media context in addition to my prompt. Let me quickly bring this snapshot here and attach in the context. Now, in this case, one thing to keep in mind is I would give the context of the entire code base and not any specific files because I want the Copilot to do that research for me based on my ask and the requirement. So I'm going to say refer to the screenshot attached. You can see that the score and the current score both of them give the same information, which is basically the score of the game, can we remove score and just keep the current score? Please suggest changes that I need to do for this requirement. Let's see what it does. Fingers crossed. Now it is basically taking a look at the code, suggesting a step-by-step solution. It has found the Flappy Bird JSX, which is sort of the file that hosts the related logic, and it has also done some changes here. I see that it has removed 5 lines. So you can see that this is the removal. We are going to do one more thing, which is the best way to test these changes, which is actually to open our game. Now let me bring the game tab here. Boom, it has successfully removed the score from here, and we do just have the current score. Excellent. Heading over back to the Visual Studio, you can also validate your changes. Looks pretty good to me. It has just removed the draw score part from our Flappy Bird JSX. So I'm going to hit keep and keep these changes, which the Copilot's edit mode has suggested for me, and also commit these changes. So let me just close the server really quick. Let me see the status. So I am on the Flappy Bird demo branch, and we have done some changes to the Flappy Bird JSX. This is the change that it has done to remove the score. What I'm going to do, use the Copilot terminal chat to just pair program with our AI. Can you tell me a command to add the latest changes and also commit them with a sensible message? Maybe we could say removing the unnecessary score text. Let's see what it does. Wonderful. So git add this particular file and then git commit with a message to remove the unnecessary score text from Flappy Bird JSX. Let me hit copy, or actually let me hit directly run. Let's see what happens. It has committed those changes. I'm going to hit git log v just to make sure I have these changes. I do have it in my Flappy Bird demo branch. Excellent. Clear this off and let's move to the next one. Now, let me run the server again just to show you what else we could improve. If you take a look at the current score as well as the high score, they are sort of overlapping or overriding the boundary of this Flappy Bird game which we are playing on. So let us try to give a prompt so that it can make it more polished and probably add some padding and margin here. Let me grab a snapshot first, and then attaching it to our chat window, and then again providing the context of the entire code base. This is important, guys. Take care of this, because sometimes then it complains that it doesn't have the entire context or some specific files that perhaps you want to take a look. So it's extremely important to give the whole context. And then what we are going to say is very similar to the last one, is please refer to the screenshot attached. You can see that the current score and high score text are overlapping with the black boundary of the game. Can you help reposition them appropriately so that it looks visually neat without any overlap? And then I can say, please suggest the necessary changes for this requirement. Seems like it has done a few things for us. Step-by-step solution, and then it has done some changes in the Flappy Bird CSS. Let's take a look. Margin top, doing some things with the padding here for the game info. Okay, the best way to test this would be again to open our actual game and see whether it has done the job for us. It has not this time, unfortunately. So let's see what else we can do to make this happen. Now, let me grab the snapshot again, then attach it here. Okay, I'll try to be a little more detailed this time. First, as you can recall, providing the context hash and the entire code base, I've attached the screenshot. And then let me just say, you got it wrong in the Flappy Bird as well as the CSS file. Adjust the position of the current score and the high score so that they don't overlap with the game canvas border. Place them neatly inside the game area at the top left and top right corners respectively with consistent padding. Ensure that the text is visually aligned, not touching the boundaries, the canvas boundary. And also say please update JSX and or CSS if needed. Now let's see what it does. Okay. So now it has suggested some changes. It has done the changes in Flappy Bird JSX, CSS. Let me quickly load the game. And by the way, you guys can see that we are doing the HMR updates here, which is the hot module replacement. So even without reloading the server itself, whatever the things that we have changed, whatever the modules that we have changed, it has just injected that into our browser, making it swift and easy to check being a developer. So let me bring the game here again. Oh, wow. Seems like it has made it better, but still not achieved the purpose, because I do see that this is overlapping with the black boundary. But I do see that this particular box, which is click or press space to start, it is being cut. So let us ask the Copilot to fix this. Heading back over to the Visual Studio Code, let me also grab the snapshot and attach it. And by the way, I've also highlighted the snapshot this time so that it has a better reference. Let me just attach it here and then ask. And before asking, providing the context of the code base, say refer to the screenshot right now. The click or press the space to start is getting cut. Please ensure the messages as well as the game over message are fully visible and centered within the canvas without being cut or clipped. Okay, the design should look clean, consistent, and neat across all the screen sizes. Please suggest the necessary changes for this requirement. Let's see what it does. It's working on it, suggesting solution, applying some edits in the Flappy Bird JSX and the CSS. Now this time claiming that it has done the job. Game messages are fully visible, centered, never clipped, regardless of the screen size. Now fingers crossed this time. It has also done some HMR updates for us, which is this one. We open the local host, bring the game here, and there we go. We have successfully placed this click or press space to start at the center now. These high score and this current score also look good to me. You can still tweak it if you want. You can position it at the top, but it's fine to me right now, so I would skip that. And then let's try to play this and see the game over screen. Lovely. We have the game over right across the center of the canvas as well. Great job, guys, on making it so far. We have a quite neat, polished game at this moment. We have also learned through this process about the edit mode, the iterations that we did in the prompt engineering for the Copilot to understand our ask. We have repeatedly also validated the code changes working as a pair programmer with the AI. So the final thing, I'm just going to close off the server. And since all these changes look good to me, I'll hit keep, and then status. And then, of course, final step, which you might have guessed, commit these changes. So again, asking the Copilot, let it do the job for us. Let it write the command. Can you tell me a command to add the latest changes to the staging area and then commit them with a sensible message? Maybe giving some hints. Polish the UI. Okay, let's see what it says. Flappy Bird. Awesome, looks good to me. I'm just going to hit run and it has done these changes for me that you can see here. All right, what's up, folks? Welcome back. Now, you guys might recall that until now, our basic implementation of Flappy Bird game just runs fine. The bird jump, the pipe moves, and when you hit the pipe, the game ends. But it still feels a little flat. What are we missing? Sound effects. Let's say when the game is over, there is no sound. Now, games are not just about visuals. Sounds definitely make them interesting. You can imagine playing Mario without the coin or the game over sound. It wouldn't feel the same way. Now, in this lesson, we are going to fix that. And guess what? Along the way, we will explore another great feature of GitHub Copilot, which is the inline chat support. You just ask the Copilot for the help right where you're coding. You don't need to switch any context or files. Or as a matter of fact, you don't even have to chat with the Copilot. You can just write an appropriate comment and then it can do the job for you. So, ready to get started? Perfect. So, right now, as you can see in the gameplay that whenever I collide with, let's say, maybe the ceiling, the game over screen comes with the final score, but there wasn't any sound effect. So, we are trying to add this sound effect with the help of the GitHub Copilot inline chat support. So, let me head back over to the Visual Studio Code. Let me go to the Flappy Bird JSX. Now, you can see that there are a bunch of functions defined here to update the canvas size, jump, maybe just at this place, let me write a comment. I would first of all add the effects and say, write a function to play the game over sound when the game is over. And there we go. You can see that as soon as we have finished writing the comment, it is already giving a suggestion for us. So you can actually hit the tab to accept it, or you can even click here and boom, we have the function. If you take a look, it's actually a pretty straightforward function. What it does is that it grabs the audio and then it just plays that audio. Now, grabbing the audio means that we need to have an audio and then we have to place it at an appropriate path that we should give here. So let's try to grab one from the internet. Now, there are a bunch of websites where you can grab this free copyright sound effects. Let's take a look at one of them, which is called the Pixabay. So let me enter pixabay.com/sound effects. Now you can just type game over here. And there you go. We have a lot of the royalty-free game over sound effects here. So let's just try to listen them. Maybe let's see. Actually, this looks good. Awesome. So I'm just going to download this with the help of this download button here to my local machine and then copy it to my clipboard. Go over to the Flappy Bird project and you see a public folder here. If you remember, we talked about that we are using this folder to store our static assets. Now this sound is also a static asset. So let me create a new folder, which is called maybe sounds. And let me put it inside the Flappy Bird, inside the public, and then go into the sounds and let me hit paste for this particular sound effect. I'm also going to copy this because I have to paste it in my Visual Studio Code for the appropriate path. Wonderful. So let us head back to the Visual Studio Code. And what we are going to do is change this path to sounds. And we're going to just paste that name. Lovely. Now, this is the function that essentially is being called to play this sound. But we actually need to call it from somewhere. So again, let me write a comment to play the game over sound when the game state changes to game over. And let's see what it does. So it is already suggesting me some code. It is asking me to use effect. If the game state changes to game over, it's going to call this function. If it looks good to me, I hit tab and this accepts it. And let me hit the save. Now we have the HMR updates going on. Never had to refresh anything. Just reloaded the whole module, which was necessary. And let me actually pull the game here so that you guys can see whether it works or not. Fingers crossed, it should work. So we have the Flappy Bird game here. Let us try to test this. And I'm going to hit the ceiling. There was a sound, so it works. But let us just see it again so that you guys can see it properly with the pipe. Lovely. So whenever the game is over, we do have the sound being played. And that is exactly what we wanted, guys. So the quick learnings. We have learned that the GitHub Copilot inline chat works very well when you provide a good comment. Also, there is one more thing that you need to know in order to use this feature. Guess what? You need to know where to write the comment. I mean, we cannot do that in the CSS file. So you need to have a high-level idea of how your code looks like. And then at appropriate places, you can comment, and then it can act as a pair programmer to serve the business logic that was intended in that comment. Okay, so this wraps up our mini lesson on the GitHub Copilot inline suggestion feature. I hope you learned something from it. We were able to add this feature with just a couple of comments. We also learned where to find the copyright-free sound clips online and how easy it is to directly integrate them into our project. Now, this inline suggestion feature is quite useful for incremental enhancements. We could try a lot of things with it. Perhaps you guys can try to even add a score sound very similar to how we added the jump sound. This would make our game very, very sound fulfilling. Perhaps we can even randomize the colors of the pipe. Or maybe another one, we could ask it to increase the difficulty of the game as our level progresses and as the bird moves forward. So this means that we have to update the pipe distance and reduce its value as our bird is progressing and leveling up. Perhaps you can even create a pause feature with it. Right now, we just have the start and the game over. So sky is the limit. It all depends on your curiosity. And don't be afraid to make experiments, because that's the best way to learn. Copilot is your best friend, is your coding partner. Suggest ideas, refine them, and see what works best. So let us know in the comments and in the Q&A what awesome enhancement you did with the help of the GitHub inline suggestion.